Students, I think yesterday we had discussed about the concept of getting things reduced, right? Um, where we had a bigger state diagram, right? And due to the similarity involved, okay, in the next state and the output contents, we were able to reduce things, right? Now, any doubts that you all have in this particular concept, or you want me to repeat it again? Because this is a very important concept.
Sir, please repeat again.
Okay, fine. So for the benefit of everyone, okay, I want you all also to involve in whatever small tasks that I give, okay, during the lecture, so that it's going to help you guys itself, okay, because see what happens is once we try to work out with few things, okay, it's only then we start understanding, okay. If you just listen, okay, then it's not going to help you out even if I explain it another 5 times as well. Okay, so I want your participation here. I want you all to work out things. Okay, then only it is possible. Now, the first thing that I want you all to do is please note down this table. All of you, I want all of you to involve. Okay. If you have done it, then it is going to be a revision for you, which is good. Please make a note of this tabulation.
Sir, I'm not able to make the diagram, the last part.
Like, what challenges are you facing, so that I can address it, you know, in a more directed
Sir,
fashion?
yes, sir. Sir, only the starting phase, like
okay,
like from where to start. It is like counter though, but the only the thing I'm facing that how to start it, like the initial thing.
okay, fine. So we have our present states here, okay, which is given as A, B, C, D, E, F, G. Now, you do not be worried as to how we got A, B, how we got C, D. Okay, this is just randomly taken for your example, okay, for your problem solving purpose. Okay, and also do not be worried as to how we got 0, 0, how we got here 0, 1. This is just a question here, right? So this is our question, and the first thing that we have to do here is we have to start off with the state diagram. Okay, always understand drawing the state diagram is very important. Okay, fine. Now, yeah, so now I hope both the table as well as the diagram is visible to all of you. Is it visible?
Yes, sir.
Okay, now let us take the first state. Okay, I will go with A. Okay, so A I will be drawing here, and now I have two possibilities. Okay, two possibilities for output 0, output 1, and the next state for x is equal to 0 and x is equal to 1. So let us first concentrate only on the first one, okay, which is state A. So in state A, okay, when x is equal to 0, which means this is your input. Okay, so this is my input. So when x is equal to 0, okay, what is my output? Output is also 0. Okay, and where is it going? It is going to the same state. So I will draw a loop here. Okay, so this indicates that I am in the same state. Okay, so this is done, and this is also done. Okay, fine. Next, when x is equal to 1, okay, when x is equal to 1, it is going to another state called B. Okay, so I will draw a line here, and I will say that A is going to be when my input is 1. When my input is 1. And when x is equal to 1, what is my output? Output is 0. So that 0, I will put it here. Any doubts here?
No, sir.
Okay. Now, let us go with the next state, which is B. Okay, B. So in B, now when x is equal to 0, it is going to C. Okay, so B is going to C when the input is 0. Okay, so this part is done. And what about the output? Output is also 0.
Output is 0, 0.
Yes, so output
So,
is
sir,
also
when output is 0, 0 or
no,
0,
no,
1, we have
no.
to write.
Don't be confused. See, not 0, 0. Output, you have to look only for x is equal to 0, because I am looking for x is equal to 0 as input, right? So
Oh,
now I have to look for only x is equal to 0 for output. Okay. So when x is equal to 1, okay, when x is equal to 1, what is my input? When x is equal to 1, for that case, what is my output? So it is column wise. Don't take it row wise. Understood? Right?
yes, sir. Now I got it.
So here, now I am for, let's see now, B is going to D when input is 1. B is going to D when input is 1. When input is 1. Okay, so this part is done. Now, what is my output here? When x is equal to 1, 0. So that is 0 I have to write here. Understood?
Yes, sir.
So you have to take it step by step. So students,
Okay,
till
sir.
this point, all of you are clear? Any doubts,
Yes,
please
sir.
ask.
No. Till
Others,
now, I mean, till here it is clear.
others, what about the others?
Yes, sir.
Okay,
Yes,
fine.
sir.
Okay. Right. So this part is also done. Right. D is done and x is equal to 1 is also done. Now go to the next state similarly. C. Okay. Now you might ask, sir, why you have put C at your right hand side? You can even put it at your left hand side. Go ahead, no problem. Some might ask, sir, why is it next to B? Why can't it put it next to you? Go ahead, no problem. Sir, can I put it next to D here at the bottom? Go ahead, no problem. Okay. The reason why I have put it here is, now if you see, I have connections between E and D, right? So I will place it somewhere in between so that it's easy for me to, connect them. You understood my point? Guys, are you understanding or not?
Yes, sir.
Yeah. See here, now you see CAD is there, right? So which means what I will do, I will keep them somewhere in between A and D. Okay. C I will place between A and D so that it becomes easy for me to connect. See, it is just like this. Now, when you're taking a house for rent, okay, maybe you have a sibling with you, okay. So, will you take a house which is near your college, or will you take a house which is near to your siblings' school? Probably you both might come up with an area which is in between both, right? For you also, it shouldn't be far. For your sibling also, it shouldn't be far, right? So that's the concept here, where I will try to um, put C, okay, put C in between so that, it looks kind of okay to connect between D and A, right? Yesterday, someone was asking, sir, is it really necessary for us to draw in a circular fashion? Is there any other way that we can do? Yes, go ahead. Any other way can be done. Okay, it's not mandate that you have to use, the technique that only I am telling you. Okay, it's not at all like that. Okay, you can go ahead. You can, the only idea here, try to understand, the only idea here is connecting this in the form of diagram. You're converting the table to a diagram form. Understanding? Yes, are you all getting it?
So we should make it as simple as possible.
That's it. Make it as simple as possible. Don't create confusions. You will also not have confusions. The person who is marking your script also will not have confusion. And ultimately, when you look at your script, it should look neat and tidy. Understood? Ultimately, confusions should be less. Neatness should be given importance. And once it is neat, you yourself will not get confused when you are trying to cross verify if all the things are put properly in your graph or not. Okay, so it's going to help you a lot, in fact, than the marker, the one who is correcting your script, than him. It is going to help you a lot in cross verifying things. And of course, if everything looks good, then there might be a chance of you getting an extra mark as well, right? Okay, so now let us go with the next state, okay, which is C. So as you can see here, C is going to state A, okay. C is going to state A when x is equal to 0. So C is going to A when my input is 0. So this is done for my input 0. Next, what is my output for the same having 0 as input? 0 is my output. Understood? Yes or no? Next, C is going to D. Okay, C is going to D when input x is equal to 1. So C is going to D, okay, when input is 1, right? So this is also done when input is 1. And what about the output here? The output is corresponding to 0. So that 0 is put here. Any doubt, students? Yes, can I have
No,
some
sir.
responses? Yeah, good.
No, sir.
So similarly, you can go ahead with D, E, F, G. Okay, let us take one more case. Let us take G. Okay, G is going to A. G is going to A when your input x is equal to 0. So at the numerator, I put 0. Now I'm waiting for the denominator value. That one I can get it from here. So 0 is here. Understood, right? So ultimately, your parameters will have two cases. Okay, it can be A or it can be B or whatever. Okay, it can have two sub cases. One is for 0 and one is for 1. And you will have to find out what is the denominator for both of these. Okay, you'll have to find out what is the denominator. Denominator means what?
Sir, output.
Output. Good. So numerator is going to be your input and your denominator is going to be the output, and this is going to be the state. Okay, so state means from that combination, okay, from say 0 0 combination, where is it going when, if in case the input is 0, if in case the input is 1, then where is it going, or is it staying in the same loop, or is the output changing? Okay, all these values you can get, in fact, the relation between input, output, and the transition from the state diagram. Clear, students? Is it clear?
Yes, sir.
Okay, fine. Nirmit, did you understand? Is your doubts cleared?
Yes, sir. Yes, sir.
Okay.
I got it.
Okay.
Thank you, sir.
Okay. So now start practicing this. Okay, for those of you who have not done it yesterday, okay, it's a very good opportunity for you to redo it and try and understand. Any doubts, please ask. See, this is not a discussion where I just throw information on you, and doesn't matter if you understand or not. No, it shouldn't be like that. Okay, it should be in such a way that we both are satisfied, me transmitting the information and then you receiving the information and digesting the information, right? So it should be a two-way process. Okay, so let's not make it a one-way process. Okay.
So what would be the applications for this, sir?
Applications, right? Now, application can be like for understanding or analyzing the circuit. Okay, you can understand the property of a circuit. Okay, if in case I give 0, is it going to the next state? Is it going to the same state, or is it having a loop? For example, it can be your traffic lights. Okay, say you are in a junction. Okay, in a junction, you can have about 4 signals, right? Towards your front, back, left and right, you can have 4 signals. So this kind of scenario will actually help us in understanding which traffic light goes green after the red one, right? So it can be traffic light 1 which is going green, and then probably traffic light 3 going green. Okay, so based on how your road congestion is. Okay, nowadays what is happening, these traffic lights are coming or going to be intelligent. Okay, so our city is going to employ that, where it is going to be smart traffic lights. So what is this smart traffic lights? Traffic lights are going to be embedded with cameras. Okay, and they will start thinking on their own. So when I say they will start thinking on their own, they will start analyzing as to how many people are there in this junction. Is it good for me to give a green signal on an empty road, or is it good for me to give a green signal on a congested road? Okay, so based on this, based on the traffic analysis, okay, your traffic light itself will decide as to which one has to go green, right? So this models here, okay, this state diagrams here will actually help to train the machine, okay, in understanding or in giving scenarios where we can understand as to from which state it is moving, it is changing from red to green. Okay, see, this ABC can all be replaced with red, green, orange, all these, right? So this is just a general format here. Okay, so applications can be n number. So this is one such example that I have given, okay, wherein your traffic lights can be analyzed, and then accordingly, if that road is getting too congested, then we can change this path. Okay, see, for example, now if A is staying in the same loop, okay, which means, let us understand that it is staying red for a long time, and that particular road is getting congested. So I will change this. I will try to change this going from A, staying in the same state A. Probably I may change it to go to state C, right? So accordingly, your counter might change. Okay, the numbers that you see, the countdown that you see, that one might change. Understanding?
Yes, sir.
Okay, so there are a lot of applications involved actually. Okay, where there are n number of things that can be done with these things. Okay, so not only that, now when we think of this reduction technique, okay, we are trying to get a smaller circuit performing the same function, which is really good, right? It is good to have a smaller thing which does the same function as your bigger circuit. So which is really good. So what is the advantage of this? Can someone tell me? What's the advantage?
Becomes more compact, sir.
Yes, becomes more compact. So because of which, how is it going to impact your IC?
So
Less
the
IC
space
space.
will be less. The
Okay.
space will be less, no?
Yes, space will be very less good. And then because of less space, what can happen? you can actually have a very small device, a very compact device, right? It will not be bulky, and you will have space for some other things
Yes,
in
sir. We
your
can add more
board.
features in that space.
Correct, correct. More features can be added, or probably if you feel that the battery backup is not good, so since your ICs are smaller, you can increase the battery size, right? So you are making room for improvement, you are making room for development, you are making room for innovations, right? When things become smaller. Okay. So just recall the example that I give you about the calculators, right? These days, your calculators can perform a lot of functions. It can even perform your conversions, octal to binary, isn't it? Binary to octal, hexadecimal, right? Many such operations, matrix calculations, all these things can be done. But previously, your calculators didn't have all these functions. Did they have the big calculators? Did they have these functions?
No, sir.
Yeah, we just had addition, subtraction, multiplication, and division, which was the only most used functionality. But these days, those are the less used, and we engineers we use a lot of matrix calculations, differentiations, integrations, right? Many such parameters. Okay, so that is going to help you in getting things reduced actually. Fine. So any doubts here? Now, students, what I want you to do is, if you have not completed the graph, okay, just go ahead and complete the graph. So all of you have completed the graph.
Yes, sir.
Okay. Fine. So can I proceed? Right. So the next step, what I will be doing is, I'll be just, giving these values here, and making sure that my graph is reduced. Okay. So A is given as 000, 1, okay, 2, 3, 4, 5, 6. Okay, all this will be given, and accordingly, okay, we will just make sure that if these are same or not. If it is same, then yes, we will eliminate. So here you can see your E and G are same, right? It both has AF and AF, and even at outputs it has 0, 1 and 0, 1. So in this case, what I'm going to do is I will just eliminate one of the state, because I do not want another state telling me the same thing happening what is in present and next state. Sorry, next state and output. Okay. So what I will do is I'll make E is equal to G. Okay. So once I make E is equal to G, once I replace E is equal to G, so this becomes G and F, right? So I can see G and F is also here, and this also has 0, 1 and 0, 1. So I will eliminate F also. So G is eliminated, F is also eliminated. So at the final, I'll be having only A, B, C, D, E. Are you clear with this point? Yes, are you all clear with this point? Yes or no?
Yes, sir.
Fine. Okay, so what is happening is we are trying to reduce the number of states. So from 1, 2, 3, 4, 5, 6, 7, from 7 states, I am reducing it to 5 states. Okay, 1, 2, 3, 4, 5. So 5 states can do the job. the whole thing that was done using 7 states, I can reduce them and get the whole thing done just using 5 states. Any doubts here, students? Okay, so accordingly, my table is going to change. Okay, my table is going to change. Any doubts, please ask. Okay, because this is an important concept. Problems can come based on these concepts. Any doubts here, students?
No, sir.
Yes, someone else has a doubt? Puneet, have you understood the concept? Puneet M.
Yes, sir.
Okay, fine. Stanley, have you understood?
Yes, sir.
Okay. How about Shiva? Shiva S.
Yes, sir.
Vinod Kumar. Vinod Kumar, have you understood the concept? Varshita. Varshita, have you
Yes, sir.
understood? Yes?
Yes, sir.
Okay,
Yes, sir.
fine. So what we are trying to do here is I am trying to change from D, I'm going to use the concept D is equal to F. Okay, why am I doing that? D is equal to F because this is GF and this is also GF. Okay, because E is equal to G. So there are two kind of substitutions here. Okay, in the first substitution, what I'm going to do is this E, I'm going to change it to G. Okay, so that is the first kind of substitution. So which means what is going to happen? Initially, I'm going to compare these two states. Once I compare these two states, since they both are same, what I will do is I will eliminate this. Okay, so that is my first step. Okay, so what am I doing here? I'm seeing that my E state is equal to G state. So the main thing here that we are trying to do is whatever information is there in a tabulation form, we are transferring it to the state diagram. Okay, so the first thing, as I was mentioning, okay, the first thing that we are going to do is we're going to see for similarities. That is number one. Okay, since I've seen that, I'm going to say my E is equal to G. Okay, so here instead of E, okay, I will replace it with G. Okay, so with this first step, I was able to do this. And in the next step, okay, what I'm going to do is I'm going to check. Okay, I'm going to check as to I have GF and GF here, right? So these two states are also the same. So what I will do is this state is already eliminated first, and then now I'll be eliminating this one also in the second step. Okay, so ultimately from 7, right? 7 is it? 1, 2, 3, 4, 5, 6, 7. From 7, I am minusing 2 states, and then I am finally coming up with 5 states, but doing the same functionality. Keep in mind the functionality is not getting changed. Okay, but then only the number of states are getting reduced, and the state diagram looks much better. Okay, because it's less occupied. Okay, and it looks more clean, right? But do you all want me to explain how the state diagram is drawn? Students, do you want me to explain about the state graph?
No, sir.
It's fine, right?
Yes, sir.
Okay, okay. So yeah, so this is about it. Okay, what I had in mind today to recall the concepts. Actually, I wanted to move into another new concept which I was mentioning in my previous lecture. About the pattern detection. But then good, you all came up with doubts. Okay, it was a good uh, session wherein we were able to discuss and understand things in a much better way. Okay, so I appreciate this kind of discussions, healthy discussions, okay, pertaining to subjects. If you have any doubts, then feel free to get back. Okay, feel free to ask doubts, and we can solve them one by one. Okay. Right. So maybe in our next lecture we will look into the pattern detectors. Okay, wherein those concepts are also important. Okay, and we will try and understand them in a much better way.